students. Welcome back to my channel. My name is Prachi Sharma, and today is another amazing session of the series Mind Mapping. Today's topic that we'll be working on is periodic table, that is your first chapter. Again, the basic concept of mind mapping is to revise the chapter in a consolidated manner and to save time. So that means if you're spending 20 minutes on this video session, it's gonna be worth it. That means in 20 minutes, you're gonna go through the entire topic and all the important portion, including the definitions, examples, and exceptions. So, without wasting any time, let's get started with periodic table. All right, students. So I hope the video is very clearly visible to you and you can see the entire notes here. So let me zoom out and show you. So again, as all our not all our mapping videos are working out, similarly you have the same concept. That means for periodic table, I have 2 pages of proper mind mapping. That means all the definitions, examples, the trends are mentioned, and on the last page I have something that I couldn't fit in the mind map. That means something different from the regular definitions. This could be any important pointers, exceptions, or diagrams that are generally mentioned in the last page. So you have these 3 pages for entire periodic table chapter, and this is majorly more on understanding the theory of it. You do not have equations. They can ask you to make an equation, that they can give you a couple of elements and they can ask you to make the equation and tell them what these two combine, if these two particular compounds combine, what will you get and what will the compound look like. So something like that you may get. Now let's get started with the understanding from the front page. Now the entire syllabus that ICC has mentioned for periodic table, it contains or it starts from the modern periodic table. It doesn't ask you anything from Newland's octaves or Daubernier's triads. So that is the reason I have not mentioned it here. If you want to do that, you can take a look at that from the book, but it's not mentioned in the ICSE syllabus provided on the website. So let's get started quickly. So we'll start now. Periodic properties. So first of all, in the modern periodic table, you have to memorize the first 20 elements and you should know their exact positioning on the table. So the first 20 are important to be learned. Other than that, whatever questions you'll get will be based upon the trends. So they will not ask you any name of the elements or anything after 20, but within 20 you are supposed to memorize that. If you're finding it difficult to memorize it, make sure that you let me know in the comment section or on the Telegram channel, and I'll make a video in which I'll tell you how to memorize those 20 elements. So let's get started with the periodic properties. So when we talk about the periodic table, we have a lot of different properties and different trends happen in the periodic table. That means if you are talking about the atomic size, so the atomic size will decrease or increase depending upon if you are going down the group or across a period. So that is what periodic properties are about. That means they are the properties that we learn about the elements and how different elements in the entire table behave as per those properties. So let's get started with the definition. So the properties of elements which are directly or indirectly related to their electronic configuration and show a regular gradation as we move across a period from left to right or down a group from top to bottom are called periodic properties. What does this mean? This means that when we talk about electronic configuration, how many valence electrons you have, or what is the valency of that particular atom, all of that defines how the element will be reactive, unreactive, and how will that element behave in certain conditions. That means if another element is coming in to combine with that particular element, will it be able to give away electrons or not, or will it be able to accept electrons or not? All of this is based upon the electronic configuration of a particular element. So that is what periodic properties are. Now let's get started with the different properties that you have in the syllabus. The first one is atomic size. So atomic size is like the radius. That means you're talking from the nucleus till the outermost shell. This particular radius, that is atomic radius, defines the atomic size of your atom. So what does this mean? This would clearly mean that if you have one shell, two shells, three shells, Whatever number of shells would increase, your atomic radius will increase, and therefore your atomic size will increase. So this means when you are coming down a group, you have one electron shell getting added up. So shells increase as you come down the group. So when you are coming down the group, the shells are increasing, therefore the size of the atom will increase. When you are going across a period, so what happens in that case is the number of shells stay the same, but there is another thing that changes. That means the number of protons in the center in the nucleus, at the nucleus, the number of protons will increase. And you know that protons have a hold on electrons which are revolving around the nucleus. So when number of protons increase, they try to have a better hold on the outermost shell, because you have more electrons in the outermost shell and you cannot afford to lose them. So protons try to have a better grasp or better grip on the outermost shell, and therefore it tries to pull it towards itself. And that is why as you go across a period, that means left to right, your atomic size decreases, because protons are trying to have a better grip on the outermost electrons. So let's quickly move ahead. So it is the distance between the center of the nucleus and the outermost shell. It depends upon, number one, number of shells, and the second is nuclear charge. What is nuclear charge? It is the how many protons are there in the center. So as your so when you see an arrow up and an arrow down, so arrow up means increasing, arrow down means decreasing in these notes. So when I say number of shells, so as number of shells increase, your atomic size also increase. Okay, as nuclear charge increase, that means number of protons increase, your atomic size decrease. Now when you are coming down a group, atomic size increase, and then example is given. Across a period, atomic size decrease, and then another example is given. Let's quickly move ahead to metallic character. So metallic character, those elements which have a tendency to lose their valence electrons and form a positive ion are considered metals. Correct? So if an element has a tendency to lose electron, that particular element is considered a metal. So let's look at it. It depends upon atomic size. Of course, if you have a bigger atomic size, it is easier for the electrons to escape from the outermost shell. And if you have a smaller atomic size, protons have a better grip on the electrons. It is difficult for electrons to escape. So this means atomic size increase, metallic character increase, nuclear charge increase, metallic character decrease. Then down a group, metallic character increases, because as you're coming down, number of shells are increasing, and outermost shell will always have a tendency to lose electron as it moves away from the nucleus. When we move across a period, our atomic size is decreasing, therefore the metallic character also decreases. Let's move to the next one, non-metallic character. So exactly opposite to metallic character, if an element has a tendency to accept electrons, that particular element is considered to be a non-metal. And when will that happen? If your atomic size is small and protons have a better hold, they will have a higher chance of accepting an electron, and the nuclear charge can keep it with itself. So this means when your atomic size decreases, your non-metallic character increases. And when your nuclear charge increases, your non-metallic character also increases. Let's look at the definition. Those electrons which have a tendency to gain electrons in order to attain its full octet in their outermost orbit are considered non-metals. Then down a group, non-metallic character decreases because the size is increasing. So the ability to accept becomes low. Across a period, non-metallic character increases because smaller the size, higher chances of keeping an electron. Next is chemical reactivity. The reactivity of elements depend upon their tendency to lose or gain electrons to complete their outermost orbit. So when we are going across a period, the reactivity first decreases and then increases. That means when you talk about the initial phase from sodium, magnesium, aluminium, when you have sodium, you just have one electron in the outermost shell. It is easy to give away. Magnesium has two, difficult to give away. Aluminium has three, a little bit more difficult to give away. So reactivity slightly decreases. Then silicon is least reactive, and then from phosphorus, sulfur, chlorine, reactivity increases, because at this point, for completing the octet, your electrons required keeps decreasing. You now, after silicon, you'll require 2 electrons, then 1 electron. So that's how it goes. Then down a group, metals increase and non-metals decrease. Okay. Let's move to the next one: ionization energy or energy or potential or enthalpy. The energy required to remove an electron from a neutral isolated gaseous atom and convert it into a positively charged gaseous ion is called ionization potential. The unit is electron volt per atom or kilojoule per mole. It depends upon atomic size, because when you are trying, so the amount of energy required to remove an electron from an atom. So what will it depend upon? It will depend upon how big the atom is. Will I be able to easily take out the electron or not? So it will depend on that. The second is, it will depend upon nuclear charge. How is the kind of hold the protons have at the center of the nucleus. So that will also affect how easily I can take out the electron from an atom. Now, atomic size increase, ionization energy decrease because better hold, smaller size. Nuclear charge increase, ionization energy increase. Now, down a group. So when you're talking down a group, ionization energy is decreasing, and when talking about across a period, ionization energy increases. Let's move to the next one: electron affinity or electron gain enthalpy. So it is exactly opposite of ionization energy. This is the amount of energy that is released when you are adding an electron and making it a negatively charged ion. So let's read it. The amount of energy released while converting a neutral gaseous isolated atom into a negatively charged gaseous ion by an addition of electron is called electron affinity. Unit is electron volt per atom or kilojoules per mole. Again, it depends upon atomic size. So as atomic size is decreasing, your electron affinity increases. That means you need more energy will be released. When an electron gets added, more energy will be released. Nuclear charge. As the nuclear charge increases, electron affinity also increases. Next is down a group and across a period. So down a group, electron affinity decreases because as you are coming down, it decreases. When you are going across a period, it increases. Let's move to electronegativity. The tendency of an atom or in a molecule to attract the shared pair towards itself is called electronegativity. So for example, if you have an atom and it is sharing an electron with another atom, whichever atom is more electronegative, it will pull the shared pair towards itself. So this is electronegativity. It depends upon atomic size. Of course, it will depend upon atomic size, how big or small the atom is, and what kind of pull it can have on the shared pair. Similarly, the nuclear charge also. So as atomic size increases, your electronegativity decreases. As your nuclear charge increases, your electronegativity increases. Now down a group, electronegativity decreases. Across a period, electronegativity increases. Okay. Now let's move to the next page real quick. Now in this page, I have a lot of different definitions that are specified in the book. So the first one is of periodicity. So the properties that reappear at regular intervals or in which there is a gradual variation at regular intervals are called periodic properties, and the phenomena is known as periodicity of elements. Okay, so this is basic understanding from the direct definition. Now what is the cause of periodicity? So the cause of periodicity is the reoccurrence of similar electronic configuration. So if you have a particular set of electronic configuration, that these are the number of valence electrons I have, these many shells I have, after a period of time when the electronic configuration starts repeating itself, that will also repeat how the element will behave in certain conditions. So that is the reason a particular pattern emerges in the periodic table, that is reoccurrence of similar properties when electrons show similar electronic configuration. Now let's move to periodicity. The same thing. Now it depends upon what? So it depends upon number of shells and it depends upon valency. So when we talk about number of shells, so down a group, number of shells will increase, and across a period, number of shells stays the same. When we talk about valency, so valency means how many electrons an element will gain or lose. Okay, so for example, the outermost shell has 3 electrons, so the valency is 3. Correct? That means it will lose 3 electrons and it will become stable. But if an atom has 6 electrons in the outermost shell, then the valency is 2, because it will gain 2 electrons and it will become stable. Okay, so you have to understand the valency and valence electrons are two separate concepts. So valency, when you are coming down the group, valency remains same. That means the number of shells, the number of electrons an element should lose or gain stays the same. Across a period, it first increases up to group 14, where you have silicon and carbon, and then it decreases. Okay, let's move to the next one, groups. So we have 18 vertical columns. That means when you're talking about groups, you have 18 vertical columns. So the first one is known as alkali metals, which is group A, except hydrogen. Then you have alkaline earth metals, which is group 2. Transition elements, that is group 3 to 12. Boron family, that is group 13. Carbon family is group 14. Nitrogen family is group 15. And chalcogens, that is oxygen family, is group 16. Halogens is group 17. Noble gases is group 18. I'll mark the most important ones. So the most important ones are alkali metals, alkaline earth metals, halogens, noble gases. So these are the most important ones that you have to remember. When we talk about periods, we have 7 horizontal rows. Now in notes, when we talk about cation, so cation is always smaller compared to the parent atom from which it is formed. Why is that? Because when cation is formed by the loss of electrons, so one electron is lost. As soon as an electron is lost, you have one extra proton in the nucleus, and protons will have a tendency to hold on to all the leftover electrons. So that is the reason when it tries to get a better grip on the electrons, the size decreases. Okay. Similarly, an ion is larger than the parent atom. So it's a similar concept. When you have an extra electron and the number of protons in the center becomes less, they have comparatively less hold on the electrons in the outermost shell. So the size increases. Then size of isoelectronic ions, that is, ions having the same number of electrons, depend upon the nuclear charge. Greater is the nuclear charge, smaller is the size. So what is nuclear charge? Number of protons. So greater the nuclear charge, smaller is the size. Let's move to the next one. So you have francesium, that is a radioactive element. We do not know the properties of this, they are unknown. Why did I mention it? This can come in multiple choice or exceptional question. The next is nature of oxides also show periodicity across a period, which show decreasing basic character and then becomes acidic. So if you start from sodium oxide, magnesium oxide, aluminium oxide. So sodium oxide, strongly basic. Why do we say strongly basic? Because when you combine this oxide in water, you get a strong alkali. So strong alkali means strongly basic. So strongly basic, and then aluminium oxide is amphoteric. That means depending on the situation, it can act like an acid or it can act like a base. Then feebly acidic, and then when you reach towards chlorine, it becomes most acidic. When you come down a group, basic nature of oxides increases. That means they become more and more basic. Now next you have exceptions. So atomic size. So we have discussed about atomic size. But the exception that you have to remember in this case is that when you're coming across a period and you reach chlorine. So chlorine we know is smaller in size, right? Because as you go along a period, the size of the atom decreases. But right after chlorine, the noble gases section, they are bigger in size because their octet is complete. So protons don't have an urgency to keep the electrons close to themselves. So that is the reason they are in a more relaxed zone. So the outermost shell is slightly spread out and the size is comparatively bigger than halogens. So inert gases or noble gases have a bigger atomic size compared to halogens. So let's read it. The size of the atoms of inert gases are bigger than the halogens of the same period because the outermost shell of inert gases is complete. They have the maximum number of electrons in their outermost orbit, thus the electronic repulsions are maximum. The effect of nuclear pull over the valence electrons is not seen. Hence, the size of the atom of an inert gas is bigger but not as bigger than of the alkali metals of the same period. So they are bigger to halogens, but they are not as bigger as the alkali metals, that is the first element of the period. So this is an exceptional case which can come in reasoning questions. Let's be quick and move to definitions. Nuclear charge. So it is how much positive charge you have in the nucleus of an atom. Then reducing agent. Elements which lose electrons to complete their octets are reducing agents. So metals are good reducing agents and they have a greater affinity to lose electrons. So they are strong reducing agents. Then when we come here, this is orbits. Orbits are the electrons that revolve around the nucleus in certain definitive circular paths. Those are orbits. Valency denotes the combining capacity of an atom. So it can be equal to the number of electrons in an atom that they can donate or accept. Okay, so valency is the capacity by which an element can donate or accept electrons to become stable. So that is valency. So this sheet is done again. Now let's move to the next one. So you have gradation of physical properties. So when we talk about physical properties, metals melting point and boiling point decreases down the group. Non-metals melting point and boiling point increases down the group. Melting point of elements increase up to group 14 and then decreases across a period. Then when we talk about density of elements across a period, they increase gradually to a maximum and then slight decrease may be noticed. Then density down a group always increases. Helium will have the highest ionization energy. Cesium will have the lowest ionization energy. Metals usually have low ionization energy. Non-metals have high ionization energy. As an exception in group 17, fluorine has lower electron affinity than chlorine. Very important one to remember. Then in group 16, oxygen has lower electron affinity or ability than sulfur. Why is that? Because size of fluorine in oxygen atom is very small. As a result, there are strong interelectronic repulsions and thus increasing electrons do not feel much attraction. So incoming electrons do not feel much attraction. Now next is generally metals show lower electronegativity as compared to non-metals. Thus metals are electropositive and non-metals are electronegative. Now diagonal relationship, this is important for you to remember. So properties which have increasing trend in a group, so as you go down they are increasing and as you go along a period they decrease. This is a general characteristic. That is why the elements of the second period show resemblance in properties with the next group of the third period. So this is what happens. Now what do they mean? They mean as this is your group 1, 2, 3, 4, 14. This is period 2, this is period 3. So lithium will have similar properties to magnesium. Beryllium will be similar to aluminium. Boron will be somewhat similar to silicon. So this is your diagonal relationship and these elements are known as bridge elements. So students, you can download these notes from the description box or you can join the Telegram channel where I send the notes before the video is uploaded. So you can have the notes with you when you check out the video. All right, ICSC warriors. So this was it for today's session. Today we have successfully covered the mind mapping of periodic table. One important thing is that if you are not connected on Telegram, so I do share some sample papers on the channel and the students can share their answer scripts with me on the email ID mentioned on the channel. And once I get a chance to correct those answer scripts, you can get the corrected answer scripts. Plus, whatever answer sheets are good, they will be presented on the YouTube channel. So I'll be discussing that this is how you can represent the answers and other students can learn from the way you are framing your answers. So make sure that you connect on Telegram if you have not joined it yet. Thank you so much and we'll catch up in the next session. I hope you have a wonderful